Hi, and welcome to your first online lesson of the year, guys. It's Pi Day, and originally this lesson was supposed to go on Pi Day, so it's going to be various applications of pi as we do circles. Hopefully you guys have your notes ready to go. We're starting up on page 11. So, in this first section here, we're going to be talking about how to find the area of circles. Now, this is a formula that you guys have used many times before. Now, remember that when I say area, I'm talking about the space inside of a particular object. Now in this case, I'm talking about the space that's enclosed by this circle. The formula for the area of a circle is pi times the radius squared. Now pi is a number that a lot of you guys have used before. It's a really cool number. It's irrational, which means you can't express it as a non-terminating decimal or as a fraction. There is actually also a pi key on your calculator. So on your calculator, if you press second and the caret button is above the divide sign. If you press second caret, you have a pi button right there. Otherwise, you can use the approximation 3.14 whenever we see it in these formulas, or you can use the approximation 22/7. It does not really matter. If we were at school, we'd probably do a little bit more about what we can do with pi, but this is what it is. So we can use pi to find the area of a circle. So the area is equal to pi times the radius, where r represents the radius of the circle here. The units in this case are square. Again, remember that means you got square feet, square inches, square centimeters, square whatever things you're doing, because we're talking about something that's two-dimensional. So just to review what you've probably done in elementary school and middle school, if I ask you to find the area of circle P, again, remember we name circles using the center of the circle, so circle P has a center P. I'm going to use this formula, area is equal to pi times the radius squared. In this particular problem, the radius is going to be 14 centimeters. So I'm going to find the area by doing pi times 14 centimeters times 14 centimeters. Of course, when you do centimeters times centimeters, you get square centimeters. So don't forget, in the end, you should have centimeters squared. Now, so if I do area is equal to pi times 14 times 14, I can calculate the answer in a couple of different ways. You can calculate it in terms of pi. When I say in terms of pi, that means you basically multiply all the numbers except the pi and leave just the pi there. So in this case, I would just do 14 times 14 and get 196 pi. So when you leave answers in terms of pi, you still have the number pi in your answer. It's just that you multiplied out everything else. So 196 pi centimeters squared. But in this case, I asked you to round to the nearest hundredth. So we're going to go ahead and multiply that out on the calculator. So 196 times pi is going to give me approximately 615.75 square centimeters. There we go. Now that's 615 and 75 hundredths there. Another question. In this one, I've given you guys the area. So for the question over here, I told you the area is 125 square inches. I'm still going to use the same formula. Area is equal to pi times the radius, except this time I know that the area is 125. So I can substitute that in. So 125 is equal to pi times the radius squared. Now to get the radius by itself, I'm going to have to do a few things. First of all, I need to get rid of this pi. So I can start by dividing both sides by pi. If I divide both sides by pi, I'm going to get r squared is equal to about 39.79. Now again, I did this by using the pi key on the calculator, and I'm actually not rounding. I'm leaving these numbers on the calculator screen. So now I'm going to take the square root of that number. So if I square root both sides to get the radius, I get about 6.31. Now, I'm not quite done because the question here actually asks for the diameter. Of course, you guys know the length of the diameter is going to be twice the length of a radius, because you can think of a diameter as 2 radii, just back to back there. Segment addition postulate says I can just add those together, which is the same thing as multiplying by 2 in this case. So my final answer is going to be 12.62 centimeters. Now this is not an area, so it's not going to be square centimeters. It's just the length of the diameter. All right, so for our next example, we're going to talk briefly about pizza. So at Papa John's, pizza is sold in 4 different sizes. The large size is a 14-inch pizza, and you might not know this, but at the pizza stores, when they say it's a 14-inch pizza, they mean that the diameter of the pizza is 14 inches. So the large size is a 14-inch diameter pizza, and the extra large is a 16-inch pizza. So if I ask how big a pizza is, I'm really talking about the area. How much pizza am I going to be able to eat? So the first thing we need to remember to do is that these numbers are the numbers that are given the diameters, so I need to figure out the radius first. So for a large pizza, the radius is actually going to be 7 inches. So if I do the area, it's going to be pi times 7 times 7, which is going to be 49 pi square inches. That's good enough for right now, so we'll leave our answer in terms of pi. For the extra large pizza, our radius is going to be 8. So if I do area is equal to pi times 8, I'm going to get 64 pi square inches. Okay, so pretty obviously, two different size pizzas. I'm going to have two different areas. How different is it? Does it really make a difference? We're going to come back to this in just a second, after we talk about a sector. So a sector is part of the area of a circle. So the sides of a sector are radii. So for instance, if I'm going to draw a couple of radii here from the center, so here's one radius, here's another radius. If I draw two radii, I've created two sectors. One of them I've colored blue here, so this is one sector, and there's also this one that I left white. So anytime you draw two radii, you're going to get two sectors. So blue one and a white one in this case. Now, obviously, if I find the area of one of these sectors, it's going to be smaller than the area of the entire circle. So what I can do is I can think of setting up a ratio. Think the part out of the whole thing. So if I can figure out how much this blue sector is out of the entire circle, then I can figure out what fraction of the entire area I can find. So the ratio of the area of a sector to the area of a circle is equal to the ratio of the measures of the arc and the circle. So the ratio, so the area, the sector to the entire circle, so the part to the entire area, is equal to the measure of this arc, which again is part of the circle, to the measure of the entire circle. Now the measure of the entire circle is always going to be 360. So I know that already. And the area of a circle is going to be pi times the radius squared. So the area of a sector is to the area of the entire circle, as the arc measure is the measure of the circle. But again, you know that the measure of the circle is always going to be 360, and I already know how to find the area of a circle. So on the next page, we're going to do a quick example like this, or a couple quick examples actually. Finding the area of the shaded sector. So if I think about this, for each of these circles, I can find the area of the entire circle and then set up a ratio that tells me how much this piece of the circle is out of the entire thing. So the area of the shaded part to the entire circle is going to be the same as the ratio of this arc to the entire circle. So the area that I'm looking for, the area of this shaded thing to the area of the whole circle, which is going to be pi r squared, r is 7 in this case, is equal to the ratio 110 to 360. Now there's many ways to solve from here. Solve in whatever way is most comfortable for you. If you want to just cross multiply and solve for that area, that's fine. I tend to try to get the area by itself. So I'm going to multiply both sides by the area of the circle in order to get rid of that denominator on the one side. So pi times 7 is 49 pi. So if I multiply both sides by that, I'm going to get this number, approximately 47.04. Now, you can think of it as finding the area of the circle and then taking a fraction of that area. I'm trying to find the part to the whole for that piece. Let's try another one. I want to find the area of this shaded piece here. So this piece to the entire circle is the same as the measure of this arc, which is 54 degrees, to the entire circle, which is 360. So this area is to pi r squared, which is pi times 5, as 54 is to the entire circle, 360. So pi times 5 is going to be 25 pi. I can multiply both sides by 25 pi, and I can get the area is going to be 11.78. All right, last example. This one, the area of the entire circle is going to be pi times 12 times 12. The ratio is going to be 288 to 360. So the area of the sector to the area of the whole circle is equal to this piece, which is 288, out of the entire circle, which is 360. Now pi times 12 is 144 pi. So the area is going to be 288 over 360 times 144 pi. And that's going to come out to about 361.9. Now, let's answer this question about pizza. So it turns out that they cut different size slices out of different size pizzas. So here we have the large pizza and the extra large pizza. Remember the area of the large pizza we already found on the previous page? The area of the large pizza, that's going to be 49 pi square inches. And the area of the extra large pizza, that is going to be 64 pi square inches. So for the large pizza, the central angle of one slice is 45 degrees. So the area of one slice, 249 pi, is equal to 45 out of 360. I do some multiplication, and I can find that that is actually equal to 19.24 square inches. So that's the area of one slice of pizza from a large pizza. For the extra large pizza, the central angle for one extra large slice is 36 degrees. So I can set up a ratio here, a proportion here. The area of one slice out of the entire 64 pi pizza is equal to 36 out of 360. So the area of a slice is going to be equal to about 20.11 square inches. Now, this makes sense that it would be smaller than the entire area of an entire pizza, of course. And it turns out, even though the extra large pizza is being cut into more slices, one slice of an extra large pizza is a little bit bigger than one slice of a large pizza. Something to think about. You might think, hey, let me think here. This extra large pizza is being cut into 10 pieces. So why can't I just find the area of the whole pizza and divide it by 10? Well, you actually are. Because this ratio right here, 36 over 360, that's the same as 1/10. So again, that's really what you're doing, is you're finding the area of the entire circle, and then you're finding just a fraction of that area. Same thing for the large pizza over here. This is cut into 8 slices, and 45 over 360 is exactly the same as 1/8. So you're finding the area of the entire pizza and then finding 1/8 of that. All right, just 2 more examples for this, finding the area of a sector. L and M are 2 points on circle R. So remember, circle R means that those are going to be, the circle center is going to be R. And then it says L and M are 2 points on that circle. So I have a point M and a point L that are on the circle, with radius 50 centimeters. So I can draw a radius that goes from R to L, and of course it's going to be 50 centimeters. I can also draw another radius that goes from M to R, and that's also going to be 50 centimeters. And the measure of angle LRM is 150 degrees. So that's the measure of the central angle here. So remember, if you have a central angle, then the measure of the arc is the same as the measure of the central angle. So this sector here is going to have an arc measure of 150 degrees. How big is this other arc going to be? Well, the entire circle must be 360 degrees. So if that's 150, this is going to be 360 minus that, or 210 degrees. If I want to find the areas of both sectors formed by the angle, so there's going to be a smaller 150 degree sector and then a larger 210 degree one. The area of the entire circle would be pi times radius, so I should end up with pi times 50 squared, which is about 2,500 pi square centimeters. So I should end up with 2 sectors, and both of them should be smaller than that. So if I set up some proportions, I can figure out, okay, the area of the smaller one is going to be about 3,272 and 49/100ths square centimeters. Once I have that number, technically I can just take the whole circle and subtract out this piece to find what's left, because these 2 pieces together must add up to the entire circle, which is 2,500 pi. But let's go ahead and set this up anyway. For the area of the other sector, I would set up almost the same thing, except that instead of 150, it's now 210. So I'm going to get a larger area, 4,581 and 49/100ths square centimeters. All right, go ahead and pause the video now and try the last example on your own. Hopefully you had a chance to try this one on your own. So for this one, we have circle W, and it has a radius of 5. S and R are 2 points on here, so there's going to be some points S and R on your circle, and the radius is going to measure 5. The measure of that angle is 45 degrees. So hopefully you were able to figure out the measures of these arcs here. If this one is 45, then this one over here must be 315 degrees, if I remember where I wrote it. I think I wrote it over here. Okay, well, the measure of this one over here is going to be 315 degrees. There we go. So hopefully you were able to figure out the area of the circle and the area of the two sectors. The area of the circle here is going to be pi r squared, and we're going to have two sectors, 45 degrees and 315 degrees. And hopefully you guys got those right. That concludes part 1. I'll see you guys over in part 2, the other video.